step, dude. Oh, one step. Double step.
Oh, oh no way. Nope, get out of there. Oh my God. He's gonna get hurt. Dude! A long baseball bat held near its thinner end has more rotational inertia than a short bat of the same mass. Once moving, it has a greater tendency to keep moving, but it's harder to bring it up to speed. Baseball players sometimes choke up on a bat to reduce its rotational inertia, which makes it easier to bring up to speed.
To run fast, you need to be able to maintain your speed. Your legs have one chance to slow you down, and that's right when your foot hits the ground here. Let's look at the ground-foot interface. When your foot strikes the ground exerts a force on your leg. This force is then passed along to your center of mass. The component of the force in the vertical direction is what keeps you from falling to the ground. The horizontal component of the force wants to slow you down. Running fast is all about reducing or eliminating this braking force. To reduce braking, move your footfall closer to your hips, as shown. Let's compare these side by side. In both cases, the magnitude of the force is the same, but this time, the force applied to the center of mass is more vertical, and so the braking force has been reduced. In this clip, the runner has decreased the braking force even more. Let's now look at all three cases together. You can readily see the progression from most to least braking. So remember, the key to running fast is to let off the brakes.
Piece of wood, one of them is going to rotate more quickly. Let's see which one that is. So the wooden disc rotated more quickly and won the race down the incline. That makes sense because we said that the metal ring had greater rotational inertia, so there's a greater resistance to a change in its state of motion. It's going to have a smaller rotational acceleration as it goes down the plane.
Now, guess it's lying around the office, nobody decided to put these up, so I'll use this for my experiment. If I grab this object in the middle and try to spin it, it's pretty easy. Okay? The reason is that the mass of this rod is distributed equally away from the center of rotation. However, if I grab this object at the end and now try to spin it, I can barely do it. Okay? Again, it's extremely difficult. Again, we said linear inertia was the resistance against linear acceleration. Well, rotational inertia is the resistance to rotational acceleration. So again, when I grab this object at the end, I have an extremely difficult time to make it accelerate rotationally. Okay? This is because of the way that the mass is distributed away from the center of the circle. So again, at the middle, it was easy because my masses are distributed at an equal distance away from the center of my circle. However, at this point, all of this mass is distributed very far from the center of my
Shoes feel slippery. There's dust on this cable.
Yeah, I'm sure it's covered.